This video is brought to you by MathGalaxy.com. Here we'll be reviewing division with multi-digit divisors. Just as subtraction is the reverse of addition, division is the reverse of multiplication. For example, 16,928 divided by 24 is asking 24 times what equals 16,928. One way to think about it is as a sharing process. If you had 16,928 candies or $16,928 shared among 24 people. So you have 8 single candies, 2 bars of 10, 9 boxes of 100, 6 crates of 1,000, and 1 truckload, say, with 10 crates in it. The traditional method starts from the left. You have 1 truckload and 24 people, so no one gets a truckload. 16 crates, still not enough to give 1 each. So we start with the hundreds, the boxes of candy. And you can do approximations with the lower and upper limit. So it has to be between division by 20 and 30. So 20 would go into it about 8 times. 30 would go into it about 5 times. So it's going to be between 5 and 8. So at least we don't have to check 4 and below or 9. So if we did it, we would find that we could give each 7 crates, and that would use up, 7 boxes, and that would use up 168 boxes, and we have 1 box left over. So the remainder at each subtraction should be less than the divisor, otherwise you haven't gone high enough. Okay, so now the remainder, we just don't throw it away, we convert it to the next smaller size. So that 1 box becomes 10 bars, plus we have 2 more bars of candy. Whenever you bring a size down, you have to try to share it. If you don't have enough to share, you put a 0 in there. And that uses up none of them, so we still have the 12 bars. And again, we don't throw those away. We convert 12 bars of candy to 120 single candies. Plus we have 8 more. And now we share the single candies. So again, 20 would go into it about 6 times. 30 would go into it about 4. So it's 4, 5, or 6. And it's 5, and 5 candies to each of the 24 people uses up 120, and we have 8 left. So each of the 24 people gets 705 candies plus 8 remaining. So you have to be careful with the zeros in the quotient, because if you leave it out, you would have an answer of 75, which would be wrong. An alternative method would be to do successive approximations. For example, how many multiples of 55 will get us to 20,601? And one way to start is with multiples of 10. So 1,000 multiples of 55 would be too large. That would be 55,000. So let's start with 100. So 100 multiples of 55 would be 5,500. And that gives us a remainder of 15,101. Okay, so if 100 multiples is that, then 200 multiples is going to be 11,000. So we have 4,101 left. Well, we can't do 100 multiples, so now we go to multiples of 10. So that gives us 550. So it makes it a lot easier in the multiplication part if you just use multiples with one non-zero digit. Okay, so the remainder here is 3551. And if 10 multiples are 550, then 20 multiples are going to be 1100. Gives us 2451 as remainder. And twice that, or 40 multiples, will give you twice that. So 40 multiples are going to be 2200. And we're going to have 251 left. So you can use any combination of multiples. And let's see here, 2 multiples will give us 110, which will give us 141 left. And another 2 multiples, another 110, gives us 31. And that's our final remainder. Now our total multiples of 55, we just add these up. So this gives you 330, 370, 374. So 55 times 374 plus 31 equals 20,601. Like all the alternative methods, this takes a little more writing, but the point is to help understand our counting system, because eventually students will end up using calculators for serious work. Here's another example. 1,000 multiples of 53 would be too high, so we start with 100. So that accounts for 5,300 of the 32,049. Remainder is 26,749. So twice that would give us twice that. So 200 multiples will give us 1,600. And the remainder, 16,149. So we can do another 200, 10,600 again. And we have 5549 remainder. So we can do another 100. Okay, remainder 249. Okay, so we can't do multiples of 100. So, and we can't do multiples of 10. That would be too high. So we have to go to the singles. Well, let's do twice that, which would be 106. The remainder 143. We can do 2 more multiples. And remainder of 37. And that's our final remainder. Now for our quotient, this gives you 604 by adding up all of our multiples. So 53 times 604 plus 37 equals 32,049. So note here, we didn't have to worry about the problems we had with the traditional method of worrying about zeros in the quotient. One place where you use division is in doing averages. For example, if your earnings for the week were $31 on Monday, $33 on Tuesday, $39 on Wednesday, and $29 on Thursday, what was your average daily pay? Well, an average is evening things out. So if you wanted to earn the same total in the same 4-day period, but do it more evenly, if you divide the total by 4, you would get 33. So if you earn $33 per day, you would have earned the same total. So averages are a way of evening things out. This has been a review of division with multi-digit divisors. If you want more practice, you can go to MathGalaxy.com. Thank you for listening.